In this video, we are going to learn how to write ionic equations. Now, one thing to note is that most chemical reactions take place between ions and not molecules. So, because of this reason, it's sometimes easier for us to write these equations by including ions in the equations. So, ionic equations will contain some ions in them, and these equations basically show us the reacting species in a given chemical reaction. Let's take an example of this common chemical reaction between zinc and dilute hydrochloric acid, the one that takes place during the preparation of hydrogen. So when you look at zinc, the zinc granules are normally in solid state, reacting with the dilute hydrochloric acid in aqueous state to form our zinc chloride, which is a soluble salt. So we shall have aqueous plus hydrogen gas. So we have to ensure that our equations are balanced. So since we have a 2 on chlorine, we shall have to put a 2 on hydrochloric acid. So we have our balanced equation. So one thing we shall first do is to try and write down this same equation by including the ions present at each stage. So zinc is a solid, so to remain a solid, it will not be in ionic form. Plus, now hydrochloric acid can dissolve to release the hydrogen ions, aqueous. However, we have 2 of them, so we have 2 hydrogen ions plus 2 chloride ions, because we have 2 hydrochloric acid in this equation up here. So on our product side, we shall also have zinc chloride. It is in solution form, so it being ionic, we shall have zinc chloride. It's a metal with valence 2, so 2 plus aqueous plus 2 chloride ions, aqueous. And lastly, hydrogen gas will escape, so it will not be in ionic form, so it will be a gas. So what happens that at this point we have to identify which ions are present on the left hand side of the arrow and the right hand side of the arrow. So this is our left hand side and this is our right hand side of our arrow. So we have to identify which ions are present on both sides. When you look at zinc metal, it's only on one side, so we shall ignore it. When you go to hydrogen ions, they are also only on the left hand side. We don't have them on the right hand side. However, when you look at chloride ions, we have them on the left hand side and we also have them on the right hand side. So what happens is that we shall have to cancel or cross them out because they are not participating in a reaction. If they are on the reactant side at the same time product side, that means they did not participate in the reaction. Nothing changed with them. So we shall call them spectator ions. So these chloride ions are spectator ions. Spectators don't participate in a football match, they just watch. So as such, we cancel them out because they have no value in this equation. So we shall end up having the following ionic equation when we remove the chloride ions. So we shall stay with zinc solid plus 2 hydrogen ions from the acid aqueous to form our zinc 2 plus aqueous. So our zinc will dissolve to form the zinc ions, then plus hydrogen gas. So this will be our ionic equation. However, one thing to note is that the charges must be the same on both sides. So the charges must balance. If you are to look at charges must balance. If you are to look at the left hand side of the arrow, you realize that you have a 2 plus, 2 charges or 2 positive charges. At the same time, also on the right hand side, we shall be having 2 positive charges. So one thing to note is that the charges must balance just like the number of atoms or ions. So in this case, this will be our ionic equation or net ionic equation for the reaction of the lab preparation of hydrogen gas. Yes, we shall have one more example or two, and then we shall call it a day. Let us now look at the reaction between an acid and a salt or a carbonate. So basically we are going to look at the equation for the reaction between marble chips and hydrochloric acid in the lab preparation of carbon dioxide. So when you look at our hydrochloric acid, aqueous, reacting with the calcium carbonate, the marble chips, these are usually in solid state, to form our calcium chloride. Aqueous, calcium chloride is soluble, plus carbon dioxide gas, plus water. So one thing to note is that our calcium carbonate, once it is put in the acid, it will dissolve to release the corresponding ions, as we are going to see. So we shall write the ions present. So we shall try to split each compound into its corresponding ions. So we should first balance the equation by putting here a 2. So hydrochloric acid, just like we have seen for the previous preparation of hydrogen, we shall have 2 hydrogen ions, aqueous, plus 2 chloride ions, aqueous. The calcium carbonate, we shall also have calcium ions into solution, aqueous, plus the carbonate ions, also aqueous, to form our calcium chloride, which is a soluble salt. Now calcium valence 2, so 2 plus aqueous, plus 2 chloride ions in the calcium chloride, valence 1 aqueous, plus our carbon dioxide gas. Now the gas will escape, it's a molecule, it's not in ionic form, just like water will also remain a molecule and not an ion. So at this point we shall have to look for our spectator ions, those ions that are both on the left hand side of the arrow and on the right hand side of the arrow. And in this case we shall have to cancel them out because they are not participating in the reaction. So when we try to scan through this, we shall see that calcium ions are on the left and on the right, just like the chloride ions are on the left and on the right. So what we shall remain with will be our ionic equation. So we shall have our hydrogen ions, 2 plus aqueous. That means our hydrogen ions will react with the carbonate ions from the marble chips, 2 minus, to form our carbon dioxide gas plus water. So this will be our ionic equation for the lab preparation of carbon dioxide. Take note that the ions cancel out. So in this case, this side we shall have no net charge on the left hand side, just like this side we have no charge. So charges must cancel out, or they must be equal on the left and the right. So this becomes the net ionic equation for the lab preparation of carbon dioxide. Lastly, we are going to have a summary of one other common ionic equation. So we all know that acids and hydroxides, we shall always form salt and water. So when we have our maybe sodium hydroxide, so if we have sodium hydroxide reacting with hydrochloric acid, we shall always form salt and water, which is our sodium chloride, and then water, because sodium chloride is the salt plus water. So feel free to try out this net ionic equation for this reaction. Sodium hydroxide aqueous reacting with hydrochloric acid aqueous to form sodium chloride aqueous, it's a soluble salt, plus water, which is a liquid. Feel free to pause the video as I give you a couple of seconds. Okay, thank you. Hopefully we are able to find the correct net ionic equation. So the correct net ionic equation will be hydroxide ions, or maybe let me start with positively charged hydrogen ions because I'm used to that. So we shall write the hydrogen ions aqueous will combine with the hydroxide ions from the sodium hydroxide to form our water. So this is the net ionic equation for acid-base reactions to produce water. That's why it's also called the neutralization reaction, because water is formed and it's neutral. So we tend to neutralize the acids with the base. So this is the equation, hopefully, that you got. So let us quickly see how it is obtained. We shall write down the ions present: sodium ions aqueous plus hydroxide ions aqueous plus hydrogen ions aqueous, chloride ions aqueous from the hydrochloric acid to form our table salt, sodium chloride. The ions will be in solution form because salt is soluble in water, chloride ions, and then our water, which will be a molecule, it will not ionize. So at this point we have to identify the spectator ions and remove them out. So we shall see the sodium ion on the left with the sodium ions on the right, chloride ions, chloride ions. Then we shall remain with the hydroxide ions, which are here, hydrogen ions, which are here, and then our water. So always we can write the net ionic equation or the ionic equation for that reaction as shown below. Yes, you can feel free to try out other examples. For example, the reactions between maybe oxides and acids. Let me leave the question below. So for reactions of acids on oxides, it is a bit similar to acids on hydroxides. So we shall have the following ionic equation being obtained. You can try and find out some equations that you can try to narrow down so that you obtain this ionic equation. So you shall have your oxide. From the oxide that you'll have used, usually you can leave it as solid to form our water. Okay, we shall stop here. Please look for questions of writing ionic equations, acids, bases, acids, carbonates, acids, hydrogen carbonates, and try them out. Thank you for watching. Leave a comment or a question. I'll make sure that I answer you as soon as possible. See you next time.